Thank you for the opportunity to be a part of the 8th annual ICCR event today on the 24th of March 2021. My name is Shauna Gregory. I'm currently a fourth year student in Bachelor of Science with concurrent teacher education with Biology and Ag Science. For today, I'm discussing my FYP on assessing the impact of inquiry-based investigations on student engagement and scientific literacy in the Irish education context. So what are inquiry-based investigations? It is a hands-on approach of experimentation with students. It is more student-centered than traditional experimentation, as students aren't given the step-by-step instructions, but instead they have to generate the hypothesis, the aiming experiment, their method, their results, their conclusions. It aids the teacher to be a facilitator of the learning environment, and the students are the main responsibility of the learning. The current education system places emphasis on facts and memory. Practicals are not given the same time, resources and focus as theory. Investigations involve teachers given step-by-step lists for students. There are changes to the Irish education in the future. There's going to be a greater focus on student scientific literacy, the STEM, improving problem solving, teamwork, inquiry-based learning. There's going to be a greater balance between propositional and the procedural knowledge of the students. From researching my literature review, the following research question was adopted for my FYP. So, can the integration of inquiry-based investigations and 3DL question enrich students' scientific understanding? Throughout the cycles 1 and 2, I hope to have this answered. Three-dimensional learning, or 3DL, emerged from the United States. It's based on the NGSS framework, which is the next generation science standards. It is implemented by in schools investigation questions, constructing models, engaging in debates, and answering 3DL problem questions. Both investigation questions and 3DL problems questions were adopted into my intervention and was researched in particular. The level of inquiry-based investigation was used was guided, so this meant that the students were given research questions and some background information on the experimentation. The students had to generate their hypothesis, aim of experiment, their materials, their method, results, and discussion points. It involved teacher and peer formative feedback, and it also included some class discussions of their results. In this intervention, there was 2 cycles for my action research, and both had a participation number of 15 transition year students. The first cycle was 2 weeks period, and it was an implementation of agricultural science topics, osmosis and photosynthesis adaptations. And in the cycle 2, it was over 1.5 weeks, and it was looking at the topic of physical properties of soil. And the 4 main data collection points that were both used in the cycles were critical incident questionnaires, reflective journal, focus group questions, and lastly, the 3DL questions. There were a couple of changes made for the second cycle from doing analysis on the first, so there was a greater need for background information for students to ensure that they had enough information to formulate their hypothesis and organising their experiment. So more time was needed for answering the critical incident questionnaires at the end of the lesson to ensure that they were answering them fully. Less 3DL questions were asked to allow more time to answers as well, as there was 7 questions in the first cycle and it was reduced to 4 to allow for more time for problem solving and critical thinking. The 4 data collection methods mentioned earlier were critical incident questionnaires, which allowed for formative feedback from students. Reflective journals allowed teachers' observation of students. Focus group questions allowed for dialogue about the effectiveness of inquiry-based investigations, and 3DL questions allowed for the assessment of the understandings of the students and how their problem-solving skills were implemented and developed. Through quantitative and qualitative analysis, there was three main themes identified. So uncertainty around inquiry-based investigations. This was the difficulty with the write-up of the investigations with the students, and that they found it more time-consuming more than traditional experimentation. The second was interactions during these investigations. So they were working with others, so did they find it helpful working with other students, asking Mead's teacher questions, and was their student engagement increased or decreased? Scientific understanding, so allowed the teacher to identify any misconceptions. In particular, there was osmosis, and they didn't really fully understand the phenomena related to the viscous tubing and the osmosis. And lastly, that they were challenged cognitively, where they were getting to do problem solving and critical thinking during the investigation, and also with the 3DL questions. So from the critical incident questionnaires throughout the 2 cycles, there was student feedback required. So students found asking other people questions and doing class discussions helpful and affirming. They preferred inquiry-based investigations compared to the traditional style where they're given their step-by-step instructions. Inquiry-based investigations did require more thinking and problem solving to be done, and they felt that it was a more interactive class, and they had a deeper understanding of the topics at hand. So in from cycle 2 of the reflective journals filled out by me, the student teacher, there was engagement increased to exceptional, so which was a scale to 1 to 4. It was a 4 from a 3 on lesson 1. So this meant that students were participating more, that they were getting involved, they were asking more questions. From the themes identified from both the analysis, there can be 2 sections, so the benefits of inquiry-based investigations and the challenges. So the benefits are the student engagement, working with others, that they were challenged cognitively, that scientific misconceptions were identified for teachers to maybe spend more time on them. The challenges were the uncertainty around inquiry-based investigations, and in particular how to write a hypothesis and how to write the aiming experiment, that the students found it time-consuming to come up with the method, the materials, results and discussions by themselves. There were a couple of limitations obtained from this study. There was a small sample size with only 15 transition year students. There was a short time period for the study, as it was only a 10-week school placement, and 2 of those was given for the first cycle, and then the second cycle was only given 1.5 to allow for data analysis between the first and the second. And lastly, there was an absenteeism associated with the transition years and for the isolation during COVID-19. So preliminary conclusions were identified from the findings. So we had the student engagement and scientific literacy increased throughout the cycles 1 and 2. There was a deeper understanding of the agricultural science topics acquired through these inquiry-based investigations. That student question and involvement in class discussions allowed for sharing of formative feedback. And lastly, that it takes time for students to become more comfortable with carrying out these type of inquiry-based investigations. Some preliminary recommendations may be building up the level of inquiry as students progress through their education system. So introducing it maybe when they're in first year and working towards building up the level of inquiry instead of starting off in tradition year with the guided inquiry. And depending on the school culture, trying implementing inquiry-based investigation as part of a unit of learnings could be an opportunity for science collaboration between teachers. Thank you all for listening, and I hope I can answer any questions that you may have.